travel beyond the stars and unlock the mysteries of the universe.
Have you ever wondered what the very end of everything will look like? Not just the end of Earth or the Sun, but the end of the universe itself. Imagine a time so far in the future that the last star has flickered out, leaving only an endless, silent darkness. This isn't science fiction. This is the black hole era, the final, longest, and perhaps most mysterious chapter in the cosmic story. Join me as we journey to the ultimate twilight of time. To understand the end, we must first look back at the beginning. The universe began with the Big Bang, a fiery, energetic explosion that gave birth to matter, energy, space, and time. From this cosmic furnace, stars and galaxies formed. Our current era, the stelliferous era, is a time of brilliant light and cosmic activity. But this age of stars is just a fleeting moment in the grand scheme of things. Stars are born, they shine, and then they die. Over trillions upon trillions of years, the fuel for star formation will run out. The great stellar nurseries will grow cold and empty. One by one, the last red dwarfs, the longest living stars, will finally exhaust their hydrogen and fade into darkness. The universe will become a vast, cold graveyard of stellar remnants, white dwarfs, neutron stars, and the most enigmatic objects of all, black holes. This transition marks the beginning of the degenerate era, a long, dark interlude before the true final act. But even these stellar corpses are not eternal. Over unimaginable timescales, a process called proton decay, if it occurs, could slowly dissolve all matter as we know it. White dwarfs and neutron stars would evaporate into a whisper of elementary particles. The universe would become a nearly perfect vacuum, an unimaginably dilute soup of photons, neutrinos, and other fundamental particles. But something would still remain, lurking in the darkness, growing ever more dominant. The black hole. This is when the black hole era truly begins. Sometime after 10 to the power of 40 years, black holes will be the only significant, organized structures left in the cosmos. They are the ultimate cosmic survivors, the final inheritors of the universe. For a period of time that makes the current age of the universe seem like the blink of an eye, these gravitational titans will reign supreme over an empty, silent cosmos. Let's pause and consider the mystical implications here. In many ancient traditions, darkness is not merely the absence of light. It is a primal state, a source of potential, the womb from which creation emerges. The Egyptian concept of Kek, the deification of primordial darkness, or the Gnostic idea of the pleroma, the totality that exists before manifestation. Could the black hole era be seen as a cosmic return to this primordial state? A universe that has shed its complex material form and returned to a state of pure, unmanifested potential, held within the singularity of each black hole. Black holes are often seen as cosmic monsters, points of no return. But what if we reframe our perspective? What if they are not just endings, but also archives? Everything that has ever fallen into a black hole, stars, planets, perhaps even ancient civilizations, is, in some form, still there. The information is not destroyed, according to our current understanding of physics, but is scrambled and stored on the event horizon. In a metaphysical sense, black holes could be seen as the universe's ultimate memory keepers, cosmic libraries holding the story of everything that has ever been. They are the silent witnesses to cosmic history, holding the past in a gravitational embrace. But even these silent kings will not rule forever. Stephen Hawking's groundbreaking discovery in 1974 revealed that black holes are not truly black. They irradiate through a quantum mechanical process now known as Hawking radiation. Black holes slowly, incredibly slowly, lose mass and energy. They evaporate. The process is agonizingly slow. A solar mass black hole would take around 10 to the power of 67 years to evaporate. The supermassive black holes at the centers of galaxies, weighing billions of solar masses, will last for mind-boggling timescales, perhaps up to 10 to the power of 100 years. As they evaporate, they release a final, faint puff of particles and low-energy photons. This is the last gasp of structured matter in the universe. Imagine this final act. After an eon of absolute darkness and silence, a final, fleeting whisper of light is emitted as the last black hole disappears. It's the universe's final firework display, a ghostly echo of the brilliant, star-filled cosmos that once was. And then, nothing, or almost nothing. This is the beginning of the dark era. The universe will be an unimaginably vast, cold, and empty place, approaching a state of maximum entropy, or what physicists call heat death. It will be a near-perfect vacuum, populated only by a sparse, ever-expanding sea of photons, neutrinos, and other stray particles, all too far apart to ever interact again. Time itself loses its meaning when nothing happens. The cosmic story, it seems, has reached its final page. The universe has settled into a state of eternal, unchanging quiet. But is this really the end? Here, science reaches its limit, and we enter the realm of pure speculation. Some physicists propose that the universe might not die a quiet death. Could a quantum fluctuation in the empty vacuum of the dark era spontaneously create a new Big Bang? This is the idea of a cyclical universe, a cosmic phoenix rising from its own ashes. Could our universe be just one in an infinite series of universes, born and reborn from the void? Another, fascinating, though highly speculative, hypothesis is that of a Boltzmann brain, a self-aware consciousness that could spontaneously form from random fluctuations in the thermal equilibrium of the dark era. It would be a fleeting, isolated mind in an empty cosmos, a final, lonely thought before eternal silence. This idea raises profound philosophical questions about consciousness, existence, and the nature of reality itself. Is a universe that can produce a single, momentary thought truly dead? Or perhaps something even stranger could happen. What if the laws of physics themselves are not immutable? Could the universe, in its final state of near-nothingness, transition into a new state with entirely different laws? The end of our universe might not be an end, but a transformation into something so alien we cannot even begin to comprehend it. The final darkness might not be an empty stage, but a chrysalis for a new kind of reality. The black hole era forces us to confront the ultimate questions of existence. It's a cosmic memento mori, a reminder of the transience of everything we know. Yet, within this ultimate darkness, there lies a strange kind of beauty and a profound mystery. It's a testament to the universe's capacity for change, from a fiery birth to a cold, silent end, and maybe, just maybe, to a new beginning. The journey to the end of time is not just a scientific exercise, it's a philosophical meditation. It challenges our perception of time, our place in the cosmos, and the very meaning of the end. What do you think awaits in the final moments of our universe? A quiet end, a new beginning, or something else entirely? Thank you for joining me on this journey to the edge of forever. If this exploration of cosmic destiny sparked your curiosity, be sure to like this video, share it with a fellow thinker, and subscribe for more deep dives into the mysteries of the cosmos. Let's continue the conversation in the comments below.